All right, I want to go over a problem that was from section 5.1, number 40. Actually, I wrote 43 here, but I think it's actually number 41 that was assigned in the homework. So let's make a little note of that right away. That's number 41 that we're going to focus on. This problem asks us to write the equation in slope-intercept form for the perpendicular bisector of a segment with the given endpoints. Okay, so we have a segment at point A, which has coordinates -3, 1, which would be like over here somewhere, -3, 1. And then we have point B, which has coordinates 4, 3, which might be up here somewhere. Okay, so let's say that's 4, 3. I mean, I didn't draw any tick marks or anything like that, but you get a sense that it's going to look something like that. So the first thing we need to do is understand what a perpendicular bisector is. And a perpendicular bisector is a bisector. It's going to be a segment that's going to bisect this segment. So if this segment looks like that from A to B, to bisect it, we need to divide it into two congruent segments. So the first thing we're going to need to do is figure out where this midpoint is, so that we know we have two congruent segments. So the coordinates of that point are going to be the midpoint between points A and B. And if you remember back at the beginning of the year when we did this, the way you find a midpoint is essentially you take the average of the x-coordinates and the average of the y-coordinates. So for the x-coordinates, -3 plus 4 divided by 2, that's how you find the average of two numbers, and that's 1/2. And then the y-coordinates, we're going to do the average of the y-coordinates. That's 1 plus 3 divided by 2, which is 4 divided by 2, which is 2. So we have this midpoint, and its coordinates are going to be 1/2, 2, right there. So the perpendicular bisector, sorry for that little blip there, the perpendicular bisector is going to be this line that runs through that midpoint and divides the segment into two congruent segments. So if we're going to try to find the equation of this line, you should remember from your algebra that you need two things. You need a point on that line, and you need a slope. Well, the point on that line is the point, that midpoint, which is 1/2, 2. But the slope, you're like, well, how are we going to know what the slope of that line is? Well, the key is this line needs to be perpendicular to this line. So we might want to show that, drawing a little perpendicular thing there, a little right angular indicator. And so the thing that you should remember from your algebra is that the slope of perpendicular lines are opposite reciprocals. So what we need to do is say, well, even though we don't know what the slope of that red line is, we should be able to find the slope of the black segment from A to B. So let's write a little thing here that the slope of segment AB is, the formula for slope is y2 minus y1, so I'll use 3 minus 1. So I'm taking this y-coordinate minus that y-coordinate, and that goes over the difference of the x's, which will be 4 minus -3. So 4 minus -3, and we get a lovely slope of 2/7. So the slope of the black line is 2/7. And if we're going to be perpendicular to that black line segment, we need to have the opposite reciprocal. So all we have to do is realize this is no longer a mystery. Our slope of our perpendicular bisector is going to be the opposite and reciprocal of 2/7, which will be -7/2. So we can now use, probably the easiest way to write the equation of a line when you have a point and a slope is point-slope form, which is y minus the y-coordinate equals the slope times x minus the x-coordinate. So in our case, that's y minus the y-coordinate of our point is 2, and our slope is -7/2. X minus the x-coordinate is 1/2. Notice I'm using the coordinates of the point right there. That's the point that's on this line. So if we're talking about the equation of this line, we better use a point that's on that line. So 1/2 is the x-coordinate, 2 is the y-coordinate, -7/2 is the slope. They did ask for it in slope-intercept form, so that's the old y equals mx plus b. So I can just do that by distributing this in, and I'm going to get y minus 2 is equal to -7/2 x plus -7/2 times -1/2 is going to be +7/4. And then just add 2 to both sides. So I'm going to get y equals negative 7/2 x. Now, 7/4 plus 2 would be 7/4 plus 8/4 to get a common denominator, which is 15/4. So there's the version in slope-intercept form, and that's what they asked for. I am always a fan of just using point-slope form because I just think it's easier when you're given a point and a slope. Now, this is a nice little problem because you need to really understand what a perpendicular bisector is to be able to do it, but you also get to use your algebra skills from last year. Now, I would like to add a little element to this problem. This is what I'd like to do on a test or a quiz, and say, what if we knew the coordinates of the third point were 0, 15/4, and that point is the third vertex of a triangle. So if we had this point somewhere up here, let's say at 0, 15/4, I don't know exactly where that point's going to lie, but I'd be curious about that to see what kind of triangle we might have here. So that's what we're going to investigate next. Now, it's pretty clear from my picture that I just kind of sketched this quickly, and I just said, we're going to have this point up here at 0, 15/4 is going to be our third vertex of this triangle. What I'd be curious about is this point on the perpendicular bisector? And the way you tell whether a point is on a line, think about it, is here's an x-coordinate and here's a y-coordinate, and if this point is going to be on this line, that means when you plug in the x value, this x value into that x, and you plug this y value into this y value, you should get a true statement. So let's see what happens. And I think you should recognize from the coordinates here that when we put 15/4 in for y, and then we put in 0 for x, do we get a true statement? And sure enough, that goes away, and we get 15/4 equals 15/4, which means that the triangle actually looks more like this right there. And the fact that that perpendicular bisector contains that other vertex means we have a pretty special kind of triangle, because if you think about it, if we look at this triangle over here and this triangle over here, I think we could see those are going to be congruent triangles because we have a shared side and we have this length equal to this length. So by side, angle, side, this triangle is congruent to this triangle, and therefore all the corresponding parts are congruent, so that side would correspond to that side. And if this and that are equal, we have an isosceles triangle. So that's kind of a little cool little add-on to this whole thing. So there you go. There's an example of a problem where you have to find the equation of the perpendicular bisector. The key elements are, you first need to find the midpoint between the 2 points. We established that. Then we found the slope between those 2 points using y2 minus y1 over x2 minus x1. We got the slope. Then to find the perpendicular slope, in other words, the slope of the line that's perpendicular to that, we took the opposite reciprocal of that slope. And once we have the slope and a point, we can write the equation of line either y equals mx plus b form or point slope form. And that will get you the equation of that line.